Hey everyone, it's Jim
And Charles
from Valves and More, an online vintage tube store. And today in Tube Lab number 212, we're going to talk about power supply and filament noise and why it matters. But first, caution everyone, electronics and tube amplifiers can have very high voltages present, which can be lethal. Exercise extreme caution when working around them. Always consult a professional technician when in doubt. Electrical mains power is generated at the source, and the generator will either run at 50 Hertz, that's 50 revolutions per second, or 60 Hertz, 60 revolutions per second. Interestingly, Japan has two independent grid systems, one at 50 Hertz and one at 60 Hertz.
I think they were both built by different electric companies.
Yeah. But most countries will run on only one frequency. Now, why does this matter? Well, our tube amps will either have a potential for 50 Hertz hum or 60 Hertz hum. And once the mains AC is rectified into DC, that frequency doubles to either 100 Hertz or 120 Hertz. Wait, it gets worse. Each of those frequencies will have multiple harmonics of the fundamental. The fundamental is just...
That's the main signal.
The main signal.
Or the main frequency.
Or the main frequency, yeah. And you could call that the first harmonic. More commonly these days we call it the fundamental. Now, normally the harmonic distortion we get from a tube circuit is desirable. But when the harmonics are generated in the power supply, we need to filter as much of that out as possible. If you are in North America, your mains power will be 60 Hertz. So your potential noise fundamentals are 60 and 120 Hertz. And the related harmonic frequencies are 30, 120, 180, 240, and so on.
And the further the harmonics get away from the primary, the lower they tend to get.
Yeah, they'll diminish. So if the fundamental was 60 and the harmonic was 120, that would be lower. And if the next harmonic was 180, that's a multiple of 60, it would be lower still. And it would keep on going like that. Now, to make it easier to understand what in the heck these harmonics are, think of them as electrical echoes that are generated by non-linear loads, like a transformer or choke, feeding a tube circuit. Okay, now, what we've got here on the lab bench, my lab bench, is the new modern line phono preamp. And that really got us into today's topic. And what happened was we had essentially a finished design.
Mm-hmm.
But the truth is designs are never truly finished.
You can always find ways to improve them.
So... sometimes you can find ways to improve them, and sometimes you just don't know how to improve them. But at some point, all designers have to say, okay, enough. It's as good as I can possibly build it now. Mm-hmm. And then maybe a few years later, you'll come back and you'll look at it with different eyes, maybe more experience from another project, and you'll apply it to a previous design. But
in a way, that's what happened here.
Yeah, so I was listening. One of the things we do with all stages of prototype builds, and this is the first production prototype. So this is pretty much how we thought it was going to be. Circuit-wise, build-wise, even the tubes we're trying in it. And I was, we've been listening to a lot of music with the new design. And one evening last week, I was listening to some very quiet classical music with lots of quiet passages. And I could just barely hear a little bit of 60 Hertz hum. And from the sitting position. So Charles came over and measured it. And we were sitting somewhere around, 27 dB.
Yeah, somewhere around
at a normal, fairly high listening volume. Now, to put that in perspective, your ambient noise of a typical room will be about 20 to 30 dB. So the noise floor of the amp in idle at a normal listening volume was very similar to what the ambient noise floor of the room would be.
Yeah, it really wasn't that loud, but it was just barely noticeable in those quiet portions.
So what would a good partner do? He would ask his more experienced partner or more skilled partner to see if he could improve that. And a couple of hours later, you came back with an improvement.
Well, I was amazed at how quickly I was able to improve the noise floor on it.
Yeah, and it was a little tiny revision to the ground topology, and you suppressed it by 7 dB.
Yeah, we dropped the noise floor by 7 dB, and for reference, dB is not linear, so 6 dBs of change is a doubling or a halving of the volume level that you perceive.
So you have the volume, have plus a little bit,
yep,
and got it to the point where even Charles, who has really still very good hearing, you couldn't hear it.
No, not at normal listening volumes at all. We'd have to turn up our very high gain preamp after it to maximum volume to be able to hear it.
And even then we're not hearing that much.
Yeah.
So that was a really great improvement. And it got me thinking a lot about whether or not there are a lot of systems, even high-end systems, in which there is some distortion, noise floor that is down in the low frequencies and masking the actual music that you're trying to listen to. Now, the lower frequency, the bass frequencies in particular, are really hard for everything in the signal chain to reproduce. So that is everything from the instrument, the vocal, the microphone, the tape or digital recording system.
The record pressing?
Especially the record pressing.
Yep.
Getting low frequencies pressed onto a vinyl record is very, very difficult. Reproducing all of that, even if it's done really well, reproducing it well is very difficult. So what happened, though, when Charles halved the 60 hertz hum and its related harmonic frequencies, was an immediate cleaning up and clarifying and tightening up of the low bass frequencies. And it was just stunning how much of an improvement it made. It was a huge leap forward in sonics to a system that already sounded very, very good.
Yep.
So I think what might help you understand a little bit more about how these frequencies sound is, why don't we head over into the music room, and I'm going to actually play those frequencies and their related harmonics on the piano so you can actually hear them and get a sense for perhaps why these are such critical frequencies.
And why you want them in your music, but not in your power supply.
Yeah, absolutely. Well said. Okay, let's head over. Okay, we're in the music room, and I've got my electronic piano out and ready to play for you. And I'm going to use some sustain so I can hold the note for you for a little while. And let's start way at the bottom at as close to 30 hertz as I can get. And I'm going to play the wood bass on this digital piano, which actually sounds quite good. Almost as low as we can go on this keyboard. In fact, this is it. That's as low as we can go. Okay, let's move up to as close as we can get to 60 hertz. Maybe I should turn it up just a little bit. And how about 120 hertz, or as close as we can get? And a multiple of that would be about 180 hertz. Oh, that doesn't sound so good, does it? And how about 240 hertz? I think the reason why it's not sounding so good as the it's an upright bass, an upright acoustic bass. I don't know what its top note is, but it can't be much higher than that. And you normally aren't going to hear that. If we switch it over to a grand piano, it'll sound. Okay, let's get back to wood bass. Now, Charles, you've got a display that'll show us the frequency and the harmonics of that frequency. So let's try 60 hertz again.
Yeah, so if you see all those lines there, that's showing you the harmonics off of the fundamental. And yeah, there's quite a few of them there.
Okay, well, how about we head back into the lab bench? Okay, well, hopefully that helped you understand a little bit better why those frequencies and notes are so important to achieving great sound, particularly in the low end. I mean, it matters on the entire frequency band.
Of course, but it particularly affects the low end because of that power supply noise.
Yeah, yeah. Oh, well, what have you got for us, Charles?
Oh, we got some fun stuff today. We had a great shipment come in and some really interesting tubes. So let's just show off this box here. I don't know if we've actually shown one of these on camera before. This is a Xerix brand, and at least I think that's how it's pronounced.
I was going to say Zap.
And these were a common rebrander. Of course, they didn't make tubes for themselves. And one of the more common types of tubes that they rebranded were RFTs. And RFTs were East German production. And here is what we have in there. This is an RFT ECC83, also known as a 12AX7. They're one of our favorite 12AX7s out there. We don't have a lot of them because they tend to have a fairly neutral sound, but the RFTs and the Matsushitas in particular are actually really quite nice sounding. And I thought this would be fun because it shows a little bit of the rebranding shenanigans that went on here.
Yeah, the flimflammery.
Take a look at that. Xerix, London, England. Yeah, I don't think that was made in London, England. That doesn't look like a Mullard or a Braimar or an STC.
And of course, if we go back in history to when the Soviet Union and East Bloc countries were being boycotted and trade embargoed and all kinds of things, depending on who was doing what.
And probably discriminated against, too, in the public for, you wouldn't want to buy something from there, I guess, if you were really not supporting those people.
Yeah. So to get around those kinds of trade rules and stuff, distributors did all kinds of weird things.
Lots of relabeling.
Lots of relabeling and creating brand names that never existed and things like that.
And here's the exact same tube with an original RFT logo on it. So this is the New House logo, and this is one of the neat things that RFT did a lot with their factory logos, is that they stylized them to be something to do with audio. Many times they are stylized to look like a tube, and the Erfurt, somebody in the comments that's German always laughs at our pronunciation of that. I think is stylized to look sort of like a reel-to-reel deck. And again, these are just beautiful tubes.
Yeah, I've argued that logo actually is 35 mil projector reels.
Oh, it might be, yeah.
Yeah, I mean, film and film sound was huge and still is. Mm-hmm. But back in the day, of course, in the theaters, you had tube amps.
Yep.
And of course, tubes all over the place, including projecting your projecting lamp. So
we got a small number of these guys in. It's been a while since we've been able to find RFT 12AX7s, and they're a great tube, so we're always trying to find more of them, and we finally have some more matched pairs in the store.
Yeah, and finding good sounding low noise 12AX7s, vintage 12AX7s, is a real challenge. Mm-hmm. So having two options available is just super duper.
Yeah.
And talking about two options, you've got another one.
Yeah, here is our other favorite, the Matsushita, and this is always a joy whenever we get them still sealed in these plastic sleeves here. So this means this box has stayed this way since it came out of the factory, which is just incredible. So let's go ahead and open that on camera.
Charles loves unboxing.
Oh yeah, well, there is hopefully going to be a beautiful looking tube inside of here.
Well, one of the benefits of having access to a vintage tube that's never been opened is that we know that it's probably never been tested and rejected. Just move it on camera.
Yeah, there we go.
Yeah. And that's become a huge thing. In the last couple of years, rejects that end up on the resale market have become a huge problem. And you can, I mean, just because the seller has 20 new old stock tubes doesn't mean that they're 20 good new old stock tubes. And in fact, in many cases, what they are is the dregs.
Yeah, the rejects over the years, the ones that weren't quite testing good enough to be used, but weren't testing so bad to throw away.
And it's not just twin triodes like a 12AX7. We see that with power tubes all the time.
Yeah.
So, you know, a company that used to sell vintage EL34s, well, when they were selling them, they weren't vintage, they were current issue, but would buy a case lot. So they'd buy 50 or 2, 3, 4 case lots, depending on how much work they've got. Mm-hmm. And they would test and match them if they knew what they were doing. And of course, they would end up with outliers.
Yeah.
Often either extremely high or more commonly very low testing power tubes, and they wouldn't be able to match them, and they wouldn't sell them, of course. But then along comes somebody who buys up an old tube repair business and says, oh, I got a part case of power tubes,
Yeah.
all brand new. Isn't that great?
I can sell these like they're new old stock and testing perfectly. And we've got another sealed box, but this one's a little bit bigger. And I'm sure many of you will be happy to know we've gotten in some more 5AR4s.
Otherwise known as the GZ34.
Yeah, so the last batch that we were able to get in was a mixture of Muller production and Matsushita production, which was made on later Muller tooling. This batch is all Matsushita that we were able to get in, and so we have some used, testing very good, and some new old stock in the store now.
And how long did it take for the last round of 5AR4s to sell?
2 hours?
2 hours.
It was. Yeah. So
2
let's
hours.
take a look at what.
Now, I think we have more than we had last time.
We actually have 9, including this guy right here, which we haven't tested yet, but
So
I
it
think
might
it's
be
going to test good.
It might be 8. Well, you never know. I
never
just threw a tube in the garbage that was brand new and it didn't test good.
Yeah. There we go. So there is a Matsushita 5AR4 right out of the box. You can see the label looks really nice. The gettering is very dark, and sometimes that can turn people off. It doesn't quite look right, but that usually means that it has a very hard vacuum pulled on it.
Yeah.
And that's a good sign.
Later in tube manufacturing, the vacuum equipment got better and better, and as a result, the manufacturers put thinner and thinner amounts of gettering on because they didn't need as much to help absorb any stray molecules that were in the vacuum after the tube was manufactured. Mm-hmm. And of course they're pulling harder vacuums, and that discolors the gettering. So you end up with this kind of a black looking gettering. It's not a sign of a defect, it's actually a sign of a really good vacuum.
And we don't see any sign of it going white or fading around the edges here, so that looks good. And I bet you whenever I pop this on the tester later today that it's going to test out just fine, just like all of its other brothers that we
Now, do all the vintage Matsushitas have a seam top, Charles?
No, actually, we've identified at least 2 different versions of them. So we've got a seam top, and then there's a flatter top where clearly they were using a different bottle. And the flatter tops also tend to have a double halo getter in them, but otherwise the exact same plate and the exact same mica structure on the inside.
And how were they testing?
Beautiful. All of them testing, every single one that I tested today tested above new old stock by a considerable margin and tight matched.
Okay, excellent.
So there are going to be some beautiful rectifiers for you guys to put in your amps.
Yeah, and you've got them in the store already?
They're already in the store, so no waiting, no refreshing, patiently waiting for me to get them in over the weekend. They're there right now.
Okay, well, thanks a lot for doing that, Charles. And if you stayed to the very end, here's some discount codes to help you out. People have been grabbing a secret code that's really easy to figure out. And we can reach almost everybody around the world with flat rate $20 shipping. But if your order is $100 or $50 or more after discount, the shipping's on us, folks. Stay safe, everyone. This is Jim.
And Charles.
Signing off. Cheers, everyone.